Hello and welcome to lesson 5.4 over the triangle midsegment theorem. Alright, this is our first video for for chapter 5. We skipped lessons 5.1, 5.2, and 5.3. If you haven't done so already, make sure you filled out the vocabulary for lesson 5.4 in your note packet and in your vocab book, and we will begin after you've done that with the warm-up. You will notice in your note packet that I do give you the formulas you will need to find midpoint for problem number 1, to find the distances x, y, and a, b for problem numbers 2 and 3, and the slope formulas for numbers 4 and 5. So take a few moments and work out these problems of your warm-up. Also on number 6, to find the slope of a line parallel to this line, we need to put this in slope-intercept form. So you need to subtract 3x from both sides, then divide everything by 2 to find out what the slope of this line is, and then remember, slopes of parallel lines are equal. Alright, let's go ahead and take a look at what answers we should have. Midpoints, x is 3.5 and y is 8.5. The length of xy is 5, the length of AB is 10. The slope of AB is 0, the slope of xy is also 0. And then number 6, the slope of a line parallel to this would also have a slope of -3/2. Okay, today's objective is to prove and use properties of triangle midsegments. And to do the proofs in this lesson, we're actually going to do coordinate proofs, which is where we work things out in the coordinate plane and we provide an explanation sentence. So we won't be doing the full 2-column proofs, so they'll be a little bit easier. The only vocab we have is the triangle, or the midsegment of a triangle, and then you'll have some theorems to look at, but the vocab term we have is the midsegment of a triangle. And here's what that is. The midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. So if we had x and y as these midpoints, and I connect them to form segment xy, xy is a midsegment. But we could also connect y and z and get a midsegment here, and connect x and z and get another midsegment. Every triangle has 3 midsegments, and these 3 midsegments form what is called the midsegment triangle. So this little triangle inside bigger triangle PQR is called a midsegment triangle. Make sure you have all of this information written down and copied down in your note packet. So let's take a look at example 1a. We are given vertices x, y, and z of triangle xyz as -1, 8, 9, 2, and 3, -4. We are told that m and n are the midpoints of xz and yz, respectively. So m is the midpoint of xz, so I will use x and z to find the coordinates of m. And n is the midpoint of yz, so I will use y and z to find the coordinates n. We want to show that segment mn, which is a midsegment, is parallel to side xy. And we want to show that the length of mn is equal to half the length of xy. So first we're going to talk about parallel segments using their slopes. So I need to find the coordinates of m and n to be able to find the slope of segment mn, and then I can find the slope of xy using those coordinates. So step 1, find the coordinates of m and n. The midpoint of xz, which is m, we do -1 plus 3 over 2, and 8 plus -4 over 2, which gives us 1, 2. The midpoint of yz, which is n, ends up being 6, -1. So we have coordinates m, 1, 2, and n, 6, -1. So let's compare the slopes mn and xy. So you'll see here, m has the coordinates 1, 2, and n has the coordinates 6, -1. So if I do -1 minus 2 for the y coordinates, I get -3. And I do 6 minus 1 for the x coordinates, I get 5. That's -3/5. And if you go back and look at the coordinates of xy, we would do 2 minus 8 and 9 minus -1. Well, 2 minus 8 is -6. And 9 minus -1 is +10, so -6 over 10 simplifies to -3/5. So these also have the same slope. So we can say, since the slopes are the same, mn is parallel to xy. Next, we need to compare the lengths of mn and xy by using the distance formula. When you plug in your coordinates mn and xy into the distance formulas, you get 6 minus 1 squared plus negative 1 minus 2 squared equals root 34. When we work this out, 9 minus negative 1 all squared plus 2 minus 8 squared, we get 2 root 34. And actually what you get before simplifying this radical, you would get the square root of 136. But 136 can be divided by 4. So if you remember simplifying radicals that we've talked about the last couple days, we can break up the square root of 136 as the square root of 4 and the square root of 34. That makes this square root of 4 just 2. So 2 root 34 and root 34. Since mn is root 34 and xy is 2 times that, we can say mn is half of xy. So in example 1b, I want you guys to take a few moments and try and do the same thing that we just did. We need to find the coordinates of the midpoint m, since it's the midpoint of RT, and the coordinates of the midpoint n, midpoint of ST, to show that they are parallel and that mn is half of RS. So the first thing you want to do is find the coordinates of m and n using the midpoint formula. Take a few moments and pause the video. And when you're ready, click play and you'll see what the answer is. Alright, the midpoint of RT, which is m, has coordinates 1, 1. Midpoint of ST, n, is 3, 4. Remember those coordinates. We're going to use those coordinates now to find the slope of mn and compare that to the slope of RT, or RS, excuse me. The slope of mn is 3 over 2. Slope of RS is also 3 over 2. Since the slopes are equal, mn is parallel to RS. Now that we have found the slopes, we want to find and compare the heights or lengths of mn and RS. You're going to use the distance formula and your coordinates. So you're going to use the distance formula to plug in the coordinates of m and n to find that length, and the same thing for the coordinates r and s to find that length. We get mn is root 13. We get RS is square root of 52. Now 52 can be divided by 4. 4 times 13 gives you 52. The square root of 4 is 2, which is how we simplify this to 2 root 13. Since mn is root 13 and RS is 2 root 13, the length of mn is half the length of RS. So what these two examples have just shown you, and again, if you need to rewind and look at those and do some more calculations till you get what I have, that's fine, go ahead and do that. But once you have done those two examples correctly, this is what you should recognize. When I take a triangle midsegment, it will be parallel to the side of the triangle that it does not intersect, and it will also be half the length of that side to which it is parallel. So in this case, D and E are midpoints of triangle ABC. So DE is parallel to AC, and the length of DE is half the length of AC. So we can use these facts, triangle midsegment theorem, to figure out some other calculations. So let's take a look at example 2a. Let's find the measure of BD. B is a midpoint of AC, D is a midpoint of CE, so BD is a midsegment. That means it is parallel to this side AE, and it's also half the length of AE. Well, AE is 17, so if BD were to be half of that, it's half of 17, which is 8.5. Using the same example, we can also talk about the angle measure for CBD. Now, remember what we have about parallel lines cut by a transversal. If I think of BD as parallel to AE, I can find this angle measure by also looking at midsegment DF, which would be parallel to AC. Since DF is parallel to AC, we get parallel lines AC and DF cut by transversal BD. The reason I want to use these lines cut by this transversal is because they give me the measure of BDF, which is 26 degrees. I get alternate interior angles created by CBD and FDB, so this would also equal 26 degrees. DF is parallel to CA. Alternate interior angles theorem says that those angle measures are equal then. So if we substitute that angle measure, CBD measures 26 degrees. Let's try example 2C. Let's find the measure of JL. JL is parallel to the midsegment PN, which is 36 units. So if 36 is half of JL, PN is half of JL, I substitute 36 in for PN, and then multiply both sides by 2. 2 times 36 is 72. So JL is 72. Let's find PM. PM is a midsegment, so it is half of side KL by the triangle midsegment theorem. So if I plug in 97 for KL or LK, I take half of that to find PM. So we simplify that, and PM is 48.5. All right, let's go ahead and try and find the measure of angle MLK. MLK is formed by sides KL and ML. KL is a side of the triangle, and it is parallel to midsegment PM by the triangle midsegment theorem. So MP and LK are parallel by the triangle midsegment theorem. That means the angle formed here and here at L, those two angles have to be congruent because KL and PM are cut by transversal JL, and those are corresponding angles. So by the corresponding angles theorem, measure of MLK is equal to the measure of JMP. So I can substitute the 102 degree angle for JMP, and the measure of MLK is 102 degrees. So that's how we can find values using the triangle midsegment theorem. In just a moment, I'm going to put up a couple slides that show some quick extra examples using this material you've learned in the lesson. You won't necessarily find these in your note packet, but you can fill them in anywhere you have extra space, or if you want to do these on a separate sheet of paper, that's fine. But these are going to be some extra practice problems so you can get a little bit better at using the triangle midsegment theorem. All right, here is your first set of problems in what we're going to call this lesson quiz. Again, you feel free to do these on a separate sheet of paper if you would like. You want to use this diagram to find each of these measures. Well, we are given triangle ABC with midsegments EF, FD, and DE. So we have midsegment triangle DEF. And so we can find ED using BC. You can find AB using FD. And you can find the measure of angle BFE using the measure of angle FCA. Go ahead and see what answers you think you should get there, and pause the video if you need more time. Otherwise, we will go ahead and check the answers now. ED is 10, half of 20. AB is 14, twice 7. And the measure of BFE is also 44 degrees. Okay, for these next two problems, you're going to use the triangle midsegment theorem to find some values. To find the value of n, notice that this is a midsegment. If this is congruent to this, that's a midpoint. If this is congruent to this, that's also a midpoint. That makes that a midsegment, even though we don't have labels. So the midsegment, n plus 14, must be half of 3n plus 12. Or you could say 3n plus 12 equals n plus 14. Solve that equation to find n. Okay, if you need any more time, go ahead and push pause. Otherwise, we should get this answer. N does equal 16. Number 5, if you're given triangle XYZ is the midsegment triangle, we should be able to find the perimeter using these values. So what you need to do is find XY and XZ using these measurements here, and then add up all three sides to find your perimeter. If you need more time, pause the video. All right, you should get 11.5. ZY is given as 3. XZ is half of 4, or is also 4. The whole thing's not 4. VY is 4, so there's 4. So 4 plus 4 would be 8. That's how I know ZX is also 8. Also 4, I mean. And XY is half of 9, 4.5. So 4 plus 4.5 plus 3 is 11.5. All right, I've attached the worksheet to the Edmodo post. Otherwise, we will work more on this in class.